Hello everyone, this is Kenneth Brony from Tech, and welcome back to the channel. So in this series of videos, we are learning Python, and this is specifically SENG 207, Programming for Engineers. And if you have been following along, we have this structure that we have been following, and this have been put together like the chapters of a book. So currently, we are on chapter 16, where we are going to discuss loops in Python. So let me just collapse this so that we have a wider view and see what these loops are. So based on the original template I gave out, I think there are some modifications I've done over here. But then don't worry, the content is definitely going to be the same. It's just that the notes have been improved. So what are we going to use these loops for? So a loop is used for iterating over a sequence, and I'm reading from line 2. And these sequences are either a list, a tuple, a dictionary, a set, or a string. So we know what a string is. We were dealing with, for instance, name, which is our variable, and I'm going to put out a string like Nkrumah over here. So this we know as a string, and it's a string because we have declared it in this single quotation mark over here. Now this is where we can use a loop. So for instance, we are going to use a for loop, and the for loop is going to iterate through everything over here. And this is what I mean. If we have our indexing, and we know based on the knowledge that we have, the character n is going to be of index 0, then we have k as 1, then we go up to the last character, in which case that's h, going to be index of 6. So this is what a loop is going to do for us. A loop is going to go through each and every character index by index and is going to print it out for us. So I can do something like for, and we are using the for loop. So for, and we have to declare a new variable. So this new variable can be anything. So I can say for char, in which case this char is not the new variable. So I'm going to say for char in name. And you can see that this is almost like an English statement. So I'm saying that for character, which I'm calling char, in name, which is a variable I have over here, I now want to print out char. So I'm saying that loop through this, go through this sequence of characters I've put together as a string over here, and now print out every character you see. So now when I run this is exactly that we will get. So this is what is happening. Upon the first iteration, the index based on the character we have over there, for which index is 0, the character is n, and that's what you see printed out over here, because eventually we are printing character. Then upon the second iteration, the character is k, the third iteration, the character is r, and it goes on till the last character we have over here as h. Good. So this is just by we using the for loop. So the for loop is going to iterate through the whole thing, and that's how it works, unless perhaps maybe we specify a particular breakpoint or something, which we are going to look at moving forward. So now that we know this, let me just comment this one out. And like I said, we are iterating over a sequence. So we've actually tested for a string, and the other data structures we can also check for. So let's look at how we iterate through a list. So let's say we have what we've been looking for, or what we've been working at. So we have fruits, and fruit is a list. So let's say we have mango, then I'll do a comma, and let's have something like banana, and let's have something like apple, and let's have orange, and finally let's have pineapple. All right, so I'll save this, and in order for me to iterate through this, I can use the for loop. So I can say for, and I will now have to declare a new variable. So I can say for fruits, in fruits, which is this fruit with an S, that's a list. And I'll bring a colon over here. Then I'll press enter. It gets indented, as you can see over here. Now I'd want to print the fruits that I have in each when we get to the iteration. So now when I run this, we do get everything printed out over here. So everything is looking good. But let's say I want to iterate through this And for instance, when I get to Apple, I don't want to print anything else. So as it stands, everything is going to be printed out. Now I can do this. Now I can say if the fruits we get to is equal to, and I can pass in Apple over here. Then I bring in a column. I can put out the break keyword over here. So this break, the moment we get to Apple, now break, don't print the rest of the fruits we have in there. So now when I save this and run this, you see that I only get mango, banana, and apple. The moment it gets to Apple, this logic gets executed and it breaks. So orange and pineapple is not going to be printed out. So for instance, this can be an implementation for we searching through a list and trying to find a particular keyword, so, or a particular element. Let me put it that way. So whenever we get to the element, just stop the iteration and just bring it out for us. And that's where we have, or that's what we have now. Now we can use loops for a number of things, and let me just show you a practical illustration of some of the things we can do with loops. So let's say we have some numbers. So I'm going to say numbers is going to be equal to 1, 2, 3. Now let's write a program that will calculate the total of whatever elements we have in there. So currently we have 1, 2, 3, and if we are to do this off head, I believe our total is going to be 6, because 1 plus 2 plus 3 is definitely going to give us 6. So for this to happen, we need to use a loop so that at every iteration we do a summation. Okay, and the way we go about this is very simple. Now I'd want us to declare a variable we are going to call total, and total is initially going to be set to 0. So this total is 0, and now we can use the for loop to do an iteration over here. So I'm going to say for x in numbers, in which case x is going to represent each number upon each iteration. So upon the first iteration, which is index 0, x is going to be 1. Upon the second iteration at index 1, x is going to be 2. And upon the third iteration at index 2, x is going to be 3. I can now update total over here. So over here, I can say total plus is equal to x. And this total plus is equal to is possible because of we using this augmented assignment operator. So upon the first iteration, initially total was set to 0. Now upon the first iteration, x is 1. So we are going to get total is equal to 0 plus 1. Upon the second iteration, we are going to get total, which is now going to be 1 plus 2. Then upon the last iteration, we are going to get total, which is now 3 plus 3. And we do expect to see a 6 over there. Now look at something very interesting over here. If I print out x over here, and remember I said something in the time past that as far as Python is concerned, the only thing we need to worry about is our indentation. So indentation is very important. Now if I run this, we do get 1, 2, 3 over here, and that's simply because we are printing out x. But now let's print out total, and if I save this and run this, we do get 136, and we are getting 136 because we are running total on each iteration. So in order to get this working the way I want it to be presented, we need to come outside of the loop so that we now print the last instance of total from that iteration. So now when I save this and run this, we do get 6 over here. Now it doesn't matter the number of elements I put in here. If I do this, I'm not even going to bother myself counting and doing the calculation. But certainly if I run this, we do get our total over here, which is 36. You can spend time to do this summation yourself, and it can go on and on. Now, if your guess is as good as mine, we can use this for instance, calculating the factorial of a number. And that is going to be an assignment. I expect you to do that. And when we meet in class, we will actually discuss this extensively. Now, for those of you watching on YouTube, you can also try it yourself. But then I'm going to do other videos where I'm going to write simple programs to do some of these calculations. So don't worry, those videos are going to come back later. So these are some of the things we can do with loops. And let's proceed to the other things we have over here. So we can also loop through multiple lists, okay, simultaneously using the zip method. And the way we go about this is very simple. So let's say we have two lists. So let's say we have, let me call this names, okay. We have our first list and we have John. Let's have Ken. And finally, let's have Sam. So you have John, Ken, and Sam. And each of them had these scores maybe in an exams. So John had 90, Ken had 80, and for instance, Sam scored 98. So this is what we have. And let's say we are pulling this from some kind of a script or a database, and you're also pulling this. They are not joined together in any way. So we want to write a simple program that joins these numbers. Now, when we use the zip method, it's going to do a one-on-one mapping. So the first element is going to map up to the first element in the other list, and it moves on and on. So over here, we can do something like for x, y. And because we are mapping two lists, we also need to bring in two separate variables over here. So I'm going to say for x, y in, and I'm going to say zip. So I'm going to zip names and scores together. And I just have to bring out this column over here. So this x will now represent each element in names over here. And this y variable will now represent each element in the scores list over here. So I can say I want to print, and let's use a formatted string to make this a little bit readable and nice. So I'm going to use this formatted string. So I'll bring in the placeholder, and I'm going to say the name, which is now x. Okay, I'm going to say scored, and I'm going to bring in another placeholder over here, and I'll say y. And these are some of the reasons why you need to use descriptive names so that you don't miss it. So let me just say for name and score in zip, names and score, so that our variable name is descriptive over here. Good. So now I'm saying that for name, score in zip, names and score, and these two are the list, as you can see over here. I now want to print out name, which is the variable upon each iteration, and I also want to print out score, the variable upon each iteration. But then I'm putting it out in a formatted string for it to show nicely. So I'll save this, and now when I run this, I get something like that reads John scored 90, Ken scored 80, and Sam scored 98. And that's exactly what I explained. So you can use the zip method to zip two lists and iterate through simultaneously using the for loop. So this is looking good. We are going to see different examples later on in this course. So now let's look at another one we have over here, which is a range method. So the range method is very interesting. So let's say I want to iterate through a range. Let's say from 0. Let me put out a comment over here. Let's say I want to iterate through from 0 to 10. I mean, I can put this in a list, but imagine if it is from 0 to 100, or from 0 to 1,000, or from 0 to 10,000, 100,000. Then typing all these numbers becomes a little bit of a problem for me and for everyone if you don't want to waste your time. So we can use the range method. So the range method is very simple. I can say, for instance, for x in range. So now when I use range over here, I can now pass in something over here, and this something is going to be, initially it is going to be the stop index. Okay, so as you can see over here, highlighted over here, says that the stops index, and you can spend time to read what you have over here. So let's say I put in 10 over here, and I bring in my column, and now I would want to print out x. This is what is going to happen. All that I'm trying to say, based on the logic I have over here on line 35, is that my range, and of course Python indexing or counting starts from 0. So it's going to count from 0, then to 1, 3, 4, 5, till it gets to 10. But because the counting starts from 0, it is actually going to end at 9. I think I've explained this. But then the total range in terms of numbers we are going to have is 10 because the counting starts from 0. So now when I save this and run this, we do get, let me open this up a little bit. Indeed, we do get the counting starting from 0, 1, 2, 3, 4, 5, all the way to 9 over here. So the trick is, if you want to get exactly 10, then we need to increase it by 1. So now when I run this, we do get this up to 10. The counting starts from 0 and we get this up to 10. So this is looking good. Now, there's also another way of handling this. So what if you want to start from 2 and count to 10? So if you want to start from 2, then we need to specify a starting index and an ending index. So I'm just going to clear this and I want to start counting from 2. So I'll do 2 and I'll do a comma. So now you can see that this has now changed from whatever thing we saw, and this was now a starting index. So now when I bring, and let me just do this, when I do 2 and bring my cursor back to the number 2, you can see that this is now the starting index, and now we now move to the stop index, and I want to stop at 11. So I'm starting at 2 and stopping at 11. So see how the counting is going to go. Now when I run this, you could see that it starts at 2. Remember, as far as indexing goes, the starting gets counted, but then the ending is exclusive. And that's why you see from starting from 2 to 10 over here. If I'm to start from 5, then it's going to start counting from 5 to 10. And that's exactly what you see over here. So we have the counting starting from 5, 6, 7, 8, 9, 10. Good. Now there's also another example. So for instance, we can say, of course, we want to start from 0, but then we want to give a step count. So you could see that when I put out another comma, we get the step over here. And if I say the step is 2, what this simply means is, instead of counting from 0, 1, 2, it is going to give us a step. So from 0, we go to 2, then from 2, we jump to 4, and from we jump 5 to 6, and it moves on and on. So now when I run this, that's exactly what you see over here. From 0, we jumped to 2, from 2, we jumped to 4, from 4, we jumped to 6, and so on and so forth. Good. Now let's write a program, a very simple program that will make sense out of this whole range thing that we have over here. So now, this is how the story goes. Now in Ghana, we have a 4-year electoral cycle. So every 4 years we vote, and we are in our 4th republic. The 4th republic started somewhere in the year 1992. So in the year 1992, Ghana started voting. And the next year, because we are in a 4-year cycle, the next voting year was 1996. Then from 96, 4 years, we voted in the year 2000. And it went on and on. The last voting we did was in the year 2020. So this is what I want us to do. I want us to write a program that's going to output all the voting years, or all the years we voted since the 4th Republic. And that's also going to be very simple. So we can say for x in, and of course we are going to use this range because we already know what this range is. And our starting index is going to be 1992. And our ending index is going to be 2023 because that's 2023. And our step is just going to be 4. This is very simple. Now I want to print, and over here I'm going to use a formatted string over here. So I'm going to put out F, and inside of this I can say that X, which is going to be the year upon each iteration, I'll say was a voting year. So now when I save this, let me open this up a little bit and open this up. If I run this program, we get to see that 1992 was a voting year, 1996 was a voting year, 2000, and we get the last one as 2020. So clearly this is a very simple program, and you can see some of the interesting things we can do with the range method. We don't have to type every number in there. We just have to specify a starting and, for instance, an ending, and if we want to put out a step over here, depending on what we are doing, we can do that over here too. So I'll comment this out and move on to the next example that we have over here. So we can also loop through a dictionary, and I'm going to defer this to, for instance, another thing we'll be doing where we'll be dealing extensively with dictionaries. But for now, yes, we can loop through dictionaries, and we are going to see as we move along. Now let's look at this, and I have an exercise here for you. And the exercise goes like, find all the even numbers in a range. Then I would also want you to print the total number of even numbers in that range. So for instance, the range I want you to check is 0 to 50. So from 0 to 50, all the even numbers. And I'll also want you to calculate the number of even numbers. So if there are 10 even numbers, there should be a way, based on the knowledge we have now, you should know. Then I would also want you to find the sum of all numbers in the list. I think we touched on this when we were dealing with what we had over here. So the next thing is for you to look at, let me change this, find the factorial of a number. So go back into your books, you know what a factorial is, find the factorial of a number. So that's going to be an assignment. Like I said, I'm going to bring out the solutions to these in other videos I'm going to do. Alright, so this is going to be the first part of loops. And in the second part, we are going to look at the while loops. So in this first part, we looked at for loop. Now you find value in the content I'm putting out over here. Kindly support my work by subscribing to the Cambro Tech channel. Also, don't forget to hit on the notification button so that anytime I release a video, you'll be duly notified. Also, share this video with friends and family who find this content very useful. At Cambro Tech, we say learn programming. You can do it. Bye bye, and catch you in the next video.